So here is yet another power amplifier of mine. It's another one that I built. This one is based around a circuit board from Tubelab. So if you saw my Tubelab Simple SE video, this is another one of George Anderson's designs. This is the Tubelab SPP, as he calls it, or Simple Push-Pull. So this is a very straightforward push-pull amp design using EL84s for the output and 12AT7s for the input and phase splitter, and a GZ34 for the rectifier. Puts out about 20 watts in pentode mode and around 5 watts or so in triode mode. As you can see, I built this in a sort of a lock box. I had this sort of cheapo fireproof lock box laying around that was not being used. I had emptied it of its stuff, and so it looked about the right size, so I just decided to use it. Ended up being kind of a pain because there's actually fiberglass insulation in the envelope and the walls here, which made it a real pain to cut and drill because it wiped out the drill bits. But anyway, I just sort of threw this together kind of quick because basically I didn't intend to build this amplifier, or I didn't build it on purpose. Let me put it to you that way. I'll explain why in a minute. So this is actually the amp I use in my shop, this room right here. I use this in the little stack of equipment that I keep in here. Usually the stack in here is just stuff that I've been working on or stuff that needs to be worked on, but I always need an amp to drive my speakers, and so I use this guy, which is more than powerful enough. It does have some thermal issues though, which I'll talk about later. I need to cut some openings in the top plate here to let more air flow through, but for that to work I need to also make some air holes in the bottom, which I haven't done yet. So I'm going to pop the top off this thing and take a look inside, and I think I'm going to leave the top off before I put it back because I don't have time right now to make the modifications, but I don't want to overheat this thing. I don't want to melt down the transformer in there, so let's take it apart and see how it looks. Just going to pop all the tubes out. These are JJ EL84s, which are pretty nice. They're probably the better EL84s being made today as far as being able to handle high plate voltages. This amp runs a little hot, so I can't really run Russian EL84s in here. It just fries them. The input tubes are just these Jan Phillips 12AT7s, which are pretty nice 12AT7s. You can still get these surplus. They're getting pricey again, but sometimes the price comes down. I think they're still coming out on the market from the Joint Army-Navy supplies. So you can see the circuit board's down in here. This is the socket for the rectifier, but all the 9-pin sockets are at the surface. I used socket extenders to get them up here, which you'll see in a second. So let's take the screws out and pop the top off here. So there's the inside of the amp. I don't see anything too concerning right now. So these are the socket extenders that I use to raise the level of the 9-pin Novel sockets to the top of the plate while letting the octal sit low. So this is the only sort of chimney effect spot that I get where there's any airflow. But there's no intakes anywhere on this thing, so it was a bad thermal design. I threw it together quick. So the story behind this amp is, like I said, I didn't intend to build this amp necessarily. So when George Anderson at Tubelab designed the SPP board, he also wanted to sell it as a kit. So people had been asking him for years and years, is he ever going to sell his Simple SE as a kit being the board with all the parts that you need to populate the board. because you can get all the parts on Mauser or DigiKey, or and you know, you have to hunt around sometimes for the sockets. So he was just trying to make it easy for people that want to build something up quick. So he put together a couple of kits, like 3 or 4 of them, and sent them out to a few people to try to build them and see how it went. And so he sent me a kit, gave me the board, all the parts. He even gave me these 2 opera transformers, which he has like a, well, he used to have a huge surplus of these, so he just kind of gave them away. They're about the right size for this amp. They're just a, you know, simple push-pull instrument amplifier output transformer. It doesn't have an ultralinear tap or anything. This is the power transformer that I sort of scavenged. It's an old Hammond. It's meant to drop into the chassis face down, but I modified it with some brackets to sit on its end like this. This sucker gets really, really hot. Hammonds are just known for that. If you buy a power transformer from Hammond, they make, you know, all the classic stuff they've been making for decades, but they just run really, really hot. And by both in terms of temperature and in terms of voltage, the rated outputs on a lot of their transformers come up higher than they should be. It seems like they designed the primary windings for 110 volts instead of 120. So because we have 120 here in the U.S., not really 110 or 115 so much, they're running hard and hot. So just an unfortunate problem. I mean, I don't know if I'll switch this out to try to get something that runs cooler, or figure out a way to vent it better. This is a input power module. These are kind of nice. I discovered these around the time I built this. It's a combination IEC power socket like you have on your computer. It has a power switch, and it also has fuses all built in one module. That's kind of handy. There's the speaker terminals there, and the inputs are there. This is a steel chassis, and this is a noisy, crappy transformer, so it's definitely exciting, the chassis. I do get a little bit of hum if the inputs are not connected to anything, just left floating. It does pick up some hum on this amp, but if they're connected to a source, it usually kills it pretty much completely. But that tells me that there's currents running through the amp, and they're getting picked up by my cables here. I may have to change the way those are routed to help that. So looking at the board, I don't see anything too concerning. You can see a little bit of just the solder flux left over from when I soldered it, sort of caked on the circuit board here. It just means that it's getting pretty hot. I did notice that all the markings on this power resistor here are gone. They pretty much baked off. It should look like this one. I know this resistor is run really close to its maximum dissipation, and being covered up all the time, even though there is an opening right here, there's really no way for the air to flow, so I don't think I think that resistor is running really, really hot. I'm not too worried about it though, because I do plan to put a choke in here. So this is one of those options where you can leave out this resistor and put a choke in its place. I'll probably put it over here somewhere. That'll smooth out the power supply a little bit, and it'll get rid of this heat source here. So yeah, like I said, this was a kit that was given to me more or less, and I just kind of built it quick because he sent me the kit to try it out and see how easy it is to build and make sure it works and all the instructions were correct. And it went together pretty well. I found a couple of small things, but there was one issue I noticed with the way that the input stage and the phase splitter are directly coupled here. I believe it was the plate resistor on the input section. It was running, it wasn't holding the grid of the phase splitter at the right voltage, and it was causing some really strange distortion when I measured it on the scope. And I was able to modify the resistors a bit to compensate. But what I found was that it depended on what tube I ran. So there was I was using these long plate tubes from I think it was Electro-Harmonics, and long plate AT7s, and yeah, they just ran really cold, and it just caused the circuit to not operate at the right voltage. The JJs were a little bit better, but when I put these Jan tubes in there, the circuit worked perfectly. So this design, because the two stages are directly coupled, there's a little bit of a sensitivity to the tube performance. So if you build one of these and you don't have a way to measure the distortion or a scope, or you're not sure, try to find an NOS tube for the input and not a current production one, because none of the current production ones I tried worked very well. So yeah, I do still have the lid on this thing, which you can close and latch, but obviously you can't close it with the tubes in there, so I usually just take the lid off. So yeah, I'm just going to put this thing back together without the top on it, so I can just put it back in my rack behind me here in my shop and just start using it again. I'm not going to tackle the chassis today, but I just wanted to take a look at the insides, and while I was at it I figured I'd shoot a quick video to talk about yet another tube amp. So let's put this back together. So in terms of simple, as in simple push-pull, I would say that this circuit design is even simpler than George's simple SE, simple single-ended. There's no solid-state components anywhere here. There's no special plate loading, you know, constant current sources or anything like that. It's just a straight-up, straightforward, like standard design push-pull amp for EL84s. Very typical, run-of-the-mill, and very reliable. They sound good and they work well. There's really no reason to go crazy with your first amp. And this is geared for someone wanting to build their first tube amp, but needing something with a bit more power than a single-ended amp. So here you get 20 watts, which is more than enough to drive, you know, a respectable type of speaker, pretty much, especially like a bookshelf speaker. But it'll even drive a main speaker as long as they're reasonably efficient, depending what output transformer you get. This one doesn't have 4 ohm taps, I believe. I think it's only got 8 ohm taps. So anyway, yeah, that's the simple PP, simple push-pull SPP. It's funny, he had to rename his simple SE amp because some other company issued him a cease and desist. They were a new company that had a simple SE product, but it's funny, if you Google for simple SE, you will not find that product. You'll only find George's amp. So, but he had to rename it the SSE because of it. It's just ridiculous. But anyway, yep. So let's. I'm gonna take the lid off this thing because I'm always afraid it's gonna come crashing down on my tubes, and let's check to make sure it still works, which I'm sure it does, and then put it back. So the Tubelab SPP is back in the stereo rack in my shop here, and taking it for a spin. Looks like it's working good. So anyway, thanks for watching. Fire it up here. Hey there. So this is sort of an addendum, I guess, to a video that I shot a couple years ago, but I recently realized that I never actually edited the footage or uploaded it, so I'm just gonna tack this on to the end of the video. I think I might have mentioned in my first video, though I don't remember anymore. Another problem with this amp is it runs a little hot. So there was a aluminum plate that sits over the top of this. It just had one cutout for the rectifier tube. All the other tubes sort of sealed at the surface. And there was no bottom ventilation at all, so there was really no way for air to get in. There was one spot for it to get out, but that didn't matter. And the power transformer tended to run really hot. So this is the power transformer. This is a Hammond transformer. This is actually meant to be mounted flat, and it had a bell that sat on the top, but I sort of rearranged it, and I'm using it in this chassis bare. It does sort of leak some noise into the circuit, but it's not too bad. It does induce currents into the steel chassis, though, so I hopefully maybe I've addressed that a little bit too. So what I did was I cut a hole in the bottom here. So this chassis, I think I mentioned it in my original video. This is actually a security box. It's fireproof. It just happened to be the right size, and I think it was on sale or something. And I wasn't thinking like, oh, maybe there'd be something inside the walls of these, and there is. There's like a fiberglass pad. It's 2 layers of metal with a fiberglass pad in between, which is a real pain to cut through, because it dulls all your drill bits, and any kind of metal tool you use to cut it, like a Sawzall, it just takes the teeth right off. So cutting this hole in the bottom here, I ended up doing it with a die grinder, not a die grinder, but a cutoff wheel out in the garage, some air tools, and even that struggled to get through it just because it was 2 layers to get through. And so anyway, I cut this hole right below the power transformer, which is a hot spot anyway because this power transformer runs really hot. So there's now like a grate down here for it to draw air. So this is the top panel. Originally the only ventilation was around the rectifier tube here, and again there was no intake, so there really was no ventilation. So I drilled these holes in the top plate and here, so the transformer is right underneath this area here, and it's actually touching the bottom of the plate. So there's conductivity from the core of the transformer into this plate, which gets pretty hot. That'll be good for convection to sort of draw air through here. So hopefully between the intake here and the outlets here, it'll draw some air through here and not get quite so toasty inside. I have left it running for many hours, and the transformer does get very hot, but it so far has not burned out or anything on me. I haven't measured it. It's supposedly good up to I think 90 degrees C, so that is pretty hot. So anyway, yeah, so I'm just going to put this thing back together now. I just wanted to talk about some of the modifications I did. I don't know if I'll show the footage of reassembly because it's a bit of a fiddly business with all these crazy standoffs. This thing was sort of cobbled together, so it's kind of a pain. But anyway, that's where this tube amp is at right now. And hopefully I'll put it back into service in my shop because I've had 2 other amps have problems lately. One of them, the one that's in my office, turned out to be just bad tubes. They went gassy on me, and just today my Dynakit 70, Stereo 70, one of the tubes started glowing cherry red, or it was actually bright orange. Same tube, same manufacturer. I have a feeling it's a defective tube. I might make a video about that because it's really frustrating. So anyway, I may or may not show more footage of me reassembling this. I'll leave the camera rolling and we'll see how it turns out. Alright, so Humpty Dumpty's all back together again. Got the transformer mounted. I got this choke installed. So this is something that I didn't install originally because I didn't have it. I believe it's a 6 Henry 150 ohm choke. It is it's a replacement for R1 here. So if you build it the most basic way, it's a CRC filter for the B+ supply, but if you can also, there's provisions for connecting a choke to these terminals here. This particular choke is the one he had in mind. So I removed the old resistor. As you can see, all the numbering is worn off of it. Well, it's baked off of it basically. This is a 5-watt resistor, but it dissipates more like 7 or 8 watts in this design. He pushes these really hard. It held up okay, but the problem was it would oxidize the solder, and I had on one occasion I had to reflow the solder joints on it again because they started like arcing and stuff just from getting too hot. You can see the leads are kind of oxidized too. So yeah, that was overloaded. This thing will run nice and cool, so that won't be a problem. So yeah, I think I got it all back together. Got to get these heights of all these just right so that the plate comes up to the ridge here and just touches that. So hopefully I got it pretty close. I think I just was using a straight edge checking it. So let's see if we can get our plate on here. So it's a little tricky to get all the little sockets lined up. Looks pretty good. Yeah, I think I'm up against the transformer there. So yeah, so there you go. There it is all back together. I just got to put the screws in and take it for another spin. Alright, let's put the screws back in. Things don't always line up perfectly because they're dangling so far in the air, so just kind of get them all started and then tighten them all down. Alright, there we go. Let's tube it back up here. It's rectifier, input phase splitters, and the power tubes. Okay, well, amp is up and running. Looks like it's working fine. Thanks for watching.